Hello, everyone, and thank you for joining today's session. I'm excited to discuss some of the most cutting-edge data mining techniques that are shaping the financial industry today. In our fast-paced world, the ability to extract meaningful insights from vast amounts of data can provide a significant competitive advantage. At Avier Company, we are at the forefront of utilizing advanced algorithms and techniques to drive financial innovation and decision-making. Today, we will explore how these techniques not only help in predicting market trends, but also in understanding customer behavior, mitigating risks, and optimizing portfolio management. So, let's dive into the details and see how data mining transforms the landscape of finance. Hello, friends. Welcome to our YouTube channel. If you enjoy our content, please subscribe to stay updated with our new videos. Let's take a quick overview of what we'll cover today. We have structured our presentation into 12 key sections, each focusing on a specific data mining technique and its application, especially in the context of finance. 1. Major data mining techniques for business. We will start by discussing the core techniques that drive data mining in the business sector. 2. Clustering method. Next, we'll explore how clustering helps in grouping vast datasets into meaningful clusters to identify patterns and trends. 3. Association rules. This section will delve into finding relationships between variables in large databases. 4. Cleaning method. Here, we'll tackle the crucial task of cleaning data to ensure the accuracy and effectiveness of our analysis. 5. Visualization method. Visualizing data is key in interpreting complex results, and we will show some of the most effective visualization techniques. 6. Classification method. We will discuss how classification helps in assigning items to predefined categories. 7. Predictive modeling. Moving forward, we will explain how predictive modeling is used to forecast future trends based on historical data. 8. Data warehousing. This will cover the strategies for storing vast amounts of data in a way that is manageable and accessible. 9. Regression analysis. We will go through how regression analysis can be used to understand relationships among variables. 10. Neural network application in data mining. We will discuss the implementation of neural networks in mining data for pattern recognition. 11. Genetic algorithm application in data mining. Here, we will explore the use of genetic algorithms in optimization problems within data mining. 12. How decision tree works in weather forecasting. Lastly, although not directly finance-related, we'll look at a practical application of decision trees in weather forecasting, demonstrating the versatility of data mining techniques. Moving on to our first detailed discussion, let's explore the major data mining techniques that are particularly influential in the business domain. 1. Outlier anomaly detection. This technique is crucial for identifying data points that deviate significantly from the norm. In finance, this can help detect fraud or unusual market behaviors that could indicate crises or opportunities. 2. Association rule learning. Often used in market basket analysis, this technique helps in discovering interesting relations between variables in large databases. For example, it can identify which products are frequently bought together, aiding in cross-selling strategies. 3. Clustering analysis. This method is used to group a set of objects in such a way that objects in the same group are more similar to each other than to those in other groups. It's extensively used in customer segmentation. 4. Classification analysis. Classification involves predicting the category to which a particular record belongs by learning from a training set of correctly identified records. It's used in applications like loan approval, where applicants are classified as low risk or high risk. 5. Regression analysis, a statistical method for estimating the relationships among variables. It's particularly useful in forecasting financial figures such as sales and inventory levels. 6. Choice modeling. This technique understands how the choices made by customers are influenced by various attributes of the product, which can help in designing more effective marketing and product strategies. 7. Rule induction, a way to extract useful if-then rules from data based on statistical significance, often used in algorithmic trading strategies. 8. Neural network. These are algorithms modeled loosely after the human brain, capable of recognizing patterns and interpreting data with a high level of accuracy. In finance, neural networks are used for stock market predictions, credit risk modeling, and more. Each of these techniques offers unique insights and capabilities, enabling businesses to leverage their data in powerful ways to make informed decisions and gain strategic advantages. Continuing with our exploration of major data mining techniques, let's delve deeper into some additional methods and their specific applications. 1. Association rule continued. RAR-ARM, Relational Association Rule Mining. This is used to find association rules in relational databases, where relationships between different sets of data items are explored. DynFP Growth, a dynamic algorithm for finding frequent patterns in databases, crucial for adapting to changes over time in large datasets. 2. Classification, Decision Tree. This method helps in breaking down a dataset into smaller subsets, while at the same time an associated decision tree is incrementally developed. Decision trees are widely used for risk assessment and customer segmentation. Naive Bayes, a simple probabilistic classifier based on applying Bayes' theorem with strong naive independence assumptions between the features. Genetic algorithm. Used in optimization, genetic algorithms simulate the process of natural selection to generate solutions to problems by combining randomly generated solutions over several generations. 3. Prediction, statistical methods. These encompass a variety of statistical techniques, from simple linear regression to more complex methods suitable for forecasting and time series analysis. Logistic regression, specifically useful for binary classification tasks, such as predicting whether a loan will default or not. 4. Clustering, K-means, a popular method that partitions n observations into k-clusters, in which each observation belongs to the cluster with the nearest mean. dbScan, density-based spatial clustering of applications with noise. Great for identifying clusters of varying shapes and sizes in a dataset, particularly useful in identifying outlier points effectively. 5. Text mining, computational linguistic database. This involves the use of computational methods to analyze text written in natural languages to gather insights. Real text data mining. This involves mining text that originates from real-world data sources, essential for sentiment analysis, topic detection, and customer feedback analysis. These techniques represent just a snapshot of the tools available for data mining in business. As we progress through each topic today, we'll provide more detailed examples of how these techniques can be practically applied to solve real-world problems and drive business success. Let's now focus on one of the key data mining techniques we mentioned earlier, the clustering method. This method is pivotal in determining the appropriate audience for a new product and subsequently pitching or selling the product to the target audience. Illustration. The process starts with identifying potential customers who might be interested in a new product. This determination often comes from analyzing purchasing patterns, customer feedback, and other relevant data. Using clustering algorithms on the customer base allows us to divide the customers into distinct groups based on similarities in their behavior or preferences. This step is crucial because it helps in customizing marketing strategies for each group, maximizing the effectiveness of the product launch. Finally, once the clusters are defined and understood, the new product is pitched or sold to these targeted groups. Tailoring the approach in this way significantly increases the likelihood of success. Methods of clustering. 1. Partitioning method. This involves dividing the data set into several clusters where each data point belongs to exactly one cluster. This method evaluates the effectiveness of clustering by optimizing a criterion, typically a distance function. 2. Hierarchical method. Data is grouped into clusters based on their similarity, but unlike the partitioning method, hierarchical clustering creates a tree of clusters. It is very useful for hierarchical data exploration. 3. Density-based method. This method clusters the data based on high-density areas surrounded by low-bot density areas. Unlike partitioning methods, this method is capable of finding clusters of arbitrary shapes, and it is good at filtering out noise and outliers. 4. Grid-based method. In grid-based clustering, the data space is divided into a finite number of cells that form a grid structure. All clustering operations are performed on this grid structure. This method is highly efficient for large data sets as it simplifies the data space into a finite number of cells. Each of these methods has its unique strengths and applications, and the choice of method can significantly influence the effectiveness of the clustering process. Through clustering, businesses can effectively segment their market and tailor their strategies to meet the specific needs and preferences of different customer groups, thereby enhancing customer satisfaction and driving business growth. In this section, we will explore another fundamental data mining technique, association rules. This technique is utilized to uncover interesting or unique relationships between variables in a dataset, which can significantly enhance our understanding and decision-making processes in business contexts. Overview: association rules mining is particularly useful in retail and e-commerce, where understanding the relationships between different items purchased can lead to effective cross-selling strategies and improved customer satisfaction. Methods 1. Single-dimensional method. This approach involves looking for repeated instances of a specific attribute or data point within a dataset. For example, retailers might analyze their customer relationship management CRM systems to find frequent patterns of specific product purchases. This can help in identifying popular products or potential bundling options. MER2, multi-dimensional method. This method extends beyond single attributes, considering multiple points or dimensions within the dataset. Retailers might be interested in understanding how demographics like age and purchase methods, card or cash, correlate with specific buying patterns. Illustration: analysis of impromptu shopping behavior. Through statistical association, retailers can identify unexpected patterns, such as parents who come in to buy childcare supplies and are also likely to purchase specialty food and beverages. Understanding these patterns helps in targeting marketing efforts more effectively. Making purchase suggestions. For example, a customer buying a tablet might also be interested in related accessories like protective cases, cables, or additional gadgets. By identifying these associations, businesses can make intelligent product recommendations, enhancing the shopping experience and increasing sales. Through the use of association rules, businesses can not only enhance their product recommendations, but also refine inventory management and promotional strategies based on real, actionable insights derived from their own data. An often overlooked but absolutely crucial step in the data mining process is data cleaning. This involves the organization and elimination of duplicate or corrupted data and filling in null values to ensure that the information harvested is accurate and reliable. Let's look at some of the key methods involved in data cleaning. Methods 1. Verifying data. This method involves checking the formats of data points within each dataset to ensure consistency. For instance, verifying telephone numbers or email formats. This step is fundamental to avoid errors in subsequent data processing stages. 2. Converting data types. Ensuring data uniformity across a dataset is essential. This might involve sorting numerical values and ensuring that characters are properly formatted for string values. Such uniformity is vital for accurate analysis and processing. 3. Removing irrelevant data. This step involves clearing out data that is not relevant to the analysis. This might include removing outlier information that could skew the results or filtering out noise that does not contribute to meaningful insights. 4. Eliminating duplicate points. Duplicates can often skew data analysis, leading to incorrect conclusions. Removing duplicate points helps in enhancing the efficiency of the mining process and reduces errors substantially. 5. Removing errors. This includes correcting mistakes related to grammar, spelling, typographical errors, and other inconsistencies in the dataset. Cleaning these errors increases the accuracy and quality of analysis. 6. Completing missing values. Missing data can be a significant barrier to accurate analysis. Estimating values for missing data using methods such as mean substitution, regression, or interpolation ensures that the dataset is complete and representative of the real world. Effective data cleaning not only improves the quality of data analysis, but also enhances the performance of predictive models and other data-driven decision-making processes. By investing in robust data cleaning methods, businesses can derive more reliable and actionable insights from their data. Another vital aspect of data mining is data visualization. This method involves translating complex data into graphical forms that can facilitate more engaging and effective conversations with stakeholders. Let's explore the various visualization techniques that help in presenting data more clearly and efficiently. Methods of visualization: compare data, column, bar, and combo charts. These are used for comparing different categories or time periods side by side, time series and spline area, effective for displaying data trends over a period. Candle dot stick and radial charts, often used in financial markets to depict price movements. 2. Part to whole, tree map and pie charts, ideal for showing how individual parts contribute to a total. Stacked area and donut charts provide a visual breakdown of different components that make up a whole. 3. Data distribution, scatter and bubble charts, useful for observing the relationship and distribution of data points. Step area and stacked column charts help in understanding the distribution of data over different categories. 4. KPIs and gauges, bullet graph and circular gauges. These are used to display performance measures and compare them to targets. KPI and liner gauges, simple yet powerful tools for quickly displaying key performance indicators in a digestible format. 5. Geospatial data, scatter map and choropleth map. Excellent for geographic data visualization, showing how data varies across different regions or territories. Application and stakeholder engagement. Using these visualization techniques allows stakeholders to grasp complicated datasets at a glance and aids in making informed decisions based on clear, visual evidence. Effective visualizations not only convey the data, but also tell a story, guiding the viewer through the narrative behind the numbers. By employing these diverse methods, businesses can enhance the interpretability of their data, making it accessible to a wider audience, including those without technical expertise, and thereby fostering more meaningful discussions and insights. In this section, we focus on the classification method, which is a type of data analysis that involves assigning large data points to multiple categories for comparative analysis. This approach is instrumental in many industries, including finance, healthcare, and retail, to predict outcomes and make informed decisions. Methods of classification. 1. Logistic regression. This method is used for binary classification tasks, such as predicting whether an email is spam or not spam. Logistic regression calculates the probability of a particular outcome and is particularly useful for scenarios with two possible results. 2. K-nearest neighbors KNN. KNN is a straightforward and highly effective classification technique that identifies an unknown data point by comparing it to the nearest neighbors in the dataset. For example, a grocery store might use KNN to analyze customer purchase patterns to decide whether to introduce new products based on local preferences. 3. Decision trees. Decision trees involve asking a series of yes-no questions about the features of a data point to determine its classification. This method is extremely user-friendly and interpretable, making it popular for tasks like determining if a customer will default on a loan based on past financial behavior. 4. Naive Bayes. This technique applies Bayes' theorem, assuming independence between predictors. Naive Bayes is particularly good for large data sets and can be used for predicting the likelihood of different outcomes based on historical data. It's effective in real-time prediction scenarios due to its speed in handling data inputs. Application in business. These classification methods are not only powerful tools for predictive analytics but also play a crucial role in operational strategies. By effectively classifying data, businesses can better predict customer behavior, optimize marketing campaigns, manage risks, and improve decision-making processes. In summary, classification helps in enhancing the precision of the analytical models used by businesses, thereby reducing uncertainty and enhancing efficiency. As we explore further into data mining techniques, predictive modeling stands out as a powerful method that leverages historical data to make informed projections about future actions or behaviors. This approach is crucial across various sectors, including finance, marketing, and operations. Let's delve into the different methods used in predictive modeling. Methods of predictive modeling. 1. Forecast modeling. This involves generative models that use historical data to answer specific questions about future needs, such as inventory requirements. For example, determining how much stock a store should have on hand for an upcoming sale based on past sales data during similar events. MEP 2. Classification modeling. This method groups data into categories based on observed characteristics, which can help in predicting group membership for new data points. For instance, it can be used to determine whether a new applicant's loan should be approved based on the characteristics of previous applicants. 3. Cluster modeling. By clustering data into similar groups, this technique helps in identifying patterns that are not immediately apparent. This can be particularly useful in market segmentation, where customers are grouped based on purchasing behavior and preferences. 4. Time series modeling. Time series analysis involves looking at data points arranged in time order to forecast future values. This is often used in stock market predictions, economic forecasting, and resource allocation in operations management. Illustration and application. Predictive models can be particularly beneficial in manufacturing by projecting distribution needs and determining maintenance schedules to avoid downtime and optimize productivity. Retail, in predicting customer purchase patterns to adjust marketing strategies and stock levels dynamically. Business impact. The ability to forecast and predict using these models allows businesses to operate more efficiently and proactively, reducing costs and enhancing customer satisfaction by anticipating needs and trends. Whether it's improving supply chain logistics or customizing marketing campaigns, predictive modeling provides a critical competitive edge by turning raw data into actionable insights. Today, we will also discuss an essential component in the data ecosystem, particularly relevant to data mining, data warehousing. This technique involves collecting data from multiple sources and storing it in a centralized archive to facilitate business analytics. Process of data warehousing. 1. Extract. The first step involves copying both structured like names and dates and unstructured data such as photos and videos from various sources to a staging area within the data warehouse. 2. Transform. Once data is extracted, it goes through a cleaning process to filter and correct errors like incorrect spellings, formatting issues, and other inaccuracies. This step ensures the data is standardized and quality-controlled before it enters the main warehouse. 3. Load. The final step involves uploading the cleaned and transformed data into the data warehouse. From here, it can be accessed and analyzed by different departments for various purposes, such as performance tracking, market analysis, and customer behavior studies. Components of a data warehouse. Data sources. These include operational systems and flat files where the initial data is gathered. Data staging area. Here, data is processed and prepared for integration into the warehouse. Data warehouse, the main repository where cleaned and structured data is stored. It typically holds 3 types of data: raw data, the detailed records about transactions and interactions; summary data, aggregated information that is commonly used in reports; metadata, data about the data itself, which helps in managing and locating stored data. Usage in business data warehousing facilitates a range of business functions. Marketing enables segmentation and targeting based on comprehensive customer data. Sales supports sales strategies through detailed historical sales data analysis. Analytics and reporting powers complex analysis and reporting tasks across multiple business units. Illustration. Through data warehousing, organizations can segment and target their clientele more effectively. For example, a large collection of data about product searches and sales orders can be analyzed to understand customer preferences and buying behavior, helping tailor marketing efforts that are more likely to convert. In summary, data warehousing is crucial for organizations looking to leverage large volumes of data from various sources to make informed strategic decisions. Regression analysis is another crucial technique in the realm of data mining. It's used for projecting numerical values in datasets, which is essential for forecasting costs, tracking marketing behaviors, and more. This slide details the techniques and applications of regression in data mining. Techniques 1. Linear regression, used to predict a dependent variable based on one independent variable, assuming a linear relationship between the two. 2. Polynomial regression extends linear regression to model nonlinear relationships by including polynomial terms in the model. 3. Logistic regression. Despite the name, it is used for binary classification rather than regression. It predicts the probability of occurrence of an event by fitting data to a logistic curve. 4. Ridge regression addresses some of the problems of ordinary least squares by imposing a penalty on the size of the coefficients. 5. Lasso regression. Similar to ridge regression, but can shrink some coefficients to zero, effectively performing variable selection. Key applications: business and marketing planning, utilizing regression models to forecast sales, customer demand, or resource allocation. Calibration of statistical data, adjusting and calibrating instruments or systems based on regression models. Crop yield estimation, agricultural applications, where regression models predict crop yields based on various factors like rainfall and fertilizer use. Environmental modeling, using regression to analyze and predict environmental changes. Drug response modeling, in pharmaceuticals to predict the effectiveness of drugs based on patient characteristics. Satellite image analysis and financial forecasting, applying regression techniques to interpret satellite imagery or predict financial markets. Advanced regression algorithms, generalized linear models, GLMs, a flexible generalization of ordinary linear regression that allows for response variables that have error distribution models other than a normal distribution. For example, it's used in agriculture to model weather impacts on crop yields. Support vector machines, SVMs. Though primarily used for classification, SVMs can also be adapted for regression, known as SVR. They're particularly effective for text classification, speech recognition, and facial recognition tasks. Regression analysis and data mining provides a solid foundation for predictive analytics, helping businesses to make more informed decisions based on quantitative data insights. This slide presents an overview of the application of neural networks within the broader field of data mining, particularly focusing on a case study of early diagnosis of diabetes. Let's delve into the flow of data and the machine learning techniques involved. Data flow and processing. 1. Input dataset. This is the initial data collected, which may include a variety of patient health metrics necessary for diagnosing diabetes. 2. Data processing. The data undergoes normalization to scale the input variables to a range between 0 and 1. This step is crucial for neural networks and other machine learning algorithms to perform effectively, as it ensures that all input features contribute equally to the analysis. Machine learning techniques. Neural networks. These are at the core of predicting and diagnosing complex conditions like diabetes. Neural networks are capable of learning and modeling non-linear and complex relationships. K-nearest neighbors, KNN. This algorithm is used for classifying data based on the closest training examples in the feature space. Naive Bayes, a simple probabilistic classifier based on applying Bayes' theorem with strong independence assumptions between the features. Random forest, an ensemble learning method for classification, regression, and other tasks that operates by constructing a multitude of decision trees at training time and outputting the class that is the mode of the class's classification or mean prediction regression of the individual trees. AdaBoost, a boosting algorithm that can be used in conjunction with many other types of learning algorithms to improve performance. The output of the other learning algorithm's weak learners is combined into a weighted sum that represents the final output of the boosted classifier. Application: early diagnosis of diabetes. Utilization of neural networks. In the scenario of diabetes diagnosis, neural networks analyze various inputs such as patient history, lifestyle, and physical indicators to predict the likelihood of diabetes onset. Evaluation metrics. Confusion matrix, accuracy, precision, recall, F1 taught score. These metrics are used to evaluate the performance of the machine learning models. The confusion matrix helps visualize the performance of an algorithm. Accuracy measures the fraction of predictions our model got right. Precision and recall are metrics that consider false positives and false negatives, respectively, while F1 taught score provides a balance between precision and recall. By employing these diverse machine learning techniques, especially neural networks, Healthcare providers can enhance early diagnosis, which is crucial for effective management and treatment of diabetes. In this part of our presentation, we explore the application of genetic algorithms (GAs) in data mining. Genetic algorithms are a fascinating area of search and optimization inspired by Darwin's theory of natural selection, and they are particularly useful in solving complex problems where traditional methods might be inefficient. Genetic algorithm workflow 1. Start. The process begins with the creation of an initial population. These are candidate solutions to the problem at hand. 2. Evaluate fitness. Each member of the population is evaluated based on a fitness function. This function measures how fit or good the solution is relative to the problem. 3. New offspring. Based on the fitness, new offspring are generated through genetic operators like crossover, where segments of genetic material are exchanged between two parents, and mutation, where small random changes are introduced. 4. Replace. The least fit members of the population are replaced by new ones. 5. Selection of optimum solution. If the termination condition is met, this could be a certain number of generations or a satisfactory fitness level. The best solution in the population is selected. Otherwise, the process returns to the evaluation step. Key operations. Selection. This is the process of choosing which individuals get to reproduce. Typically, the fitter the individual, the higher the chance of being selected. Crossover. This genetic operator mixes the genetic information of two parents to generate new offspring, promoting genetic diversity within the population. Applications in data mining. Genetic algorithms can be used in data mining for feature selection, clustering, and optimization of complex problems. Feature selection. GAs can efficiently select the most relevant features from large datasets, improving the accuracy and efficiency of predictive models. Clustering. They can also be employed to determine the optimal number of clusters by optimizing a particular clustering criterion. Optimization problems. GAs are excellent for finding solutions to complex problems with many local optima, where other algorithms might fail to find the global optimum. The implementation of genetic algorithms in data mining can significantly enhance the ability to solve complex problems more efficiently, particularly in scenarios where adaptive iteration is crucial. This slide illustrates the practical application of decision trees in predicting outcomes based on a series of decisions. Here we use the example of weather forecasting to decide whether or not it is a good day to play golf. Decision tree structure. The decision tree starts with a dataset that includes several predictors like outlook, temperature, humidity, and windy conditions, along with a target variable, which in this case is play golf. Predictors and target. Outlook: sunny, overcast, rainy. Temperature: hot, mild, cool. Humidity: high, normal. Windy: true, false. Play golf: yes, no. Process 1. Input dataset. Data is collected with observations on weather conditions and whether or not it was a good day to play golf. 2. Data processing. Data is possibly cleaned and normalized as required, though this isn't detailed in the slide. 3. Decision tree construction. The tree is built by splitting the dataset into branches based on entropy and information gain from each of the attributes. For instance, it first splits by outlook, then further branches are made based on other attributes like windy and humidity. Decision nodes. The first decision node splits the data based on the outlook. If it is sunny, the tree checks if it is windy. Decisions follow from these conditions. Under other conditions like overcast and rainy, subsequent branches check other attributes such as humidity. Outcome. The tree leads to decisions on whether playing golf is advisable under specific weather conditions. This example simplifies complex decision-making processes into an understandable format, showing the power of decision trees in classification tasks. Application in weather forecasting. This model, though simplified, illustrates how decision trees can be used to make practical decisions in real-world scenarios like weather forecasting. The tree helps in breaking down the decision process into understandable chunks, making it an excellent tool for both predictions and explanations. In summary, decision trees are a valuable tool in data mining for making predictions based on historical data. They are widely used in various fields, including weather forecasting, to provide clear and actionable decision paths based on input conditions. Thank you all for your attention throughout this presentation on advanced data mining techniques. We've covered a range of methods today, from decision trees and neural networks to genetic algorithms and regression analysis, each providing valuable insights into different aspects of data handling and prediction. I hope this session has been informative and gives you a solid foundation to explore these techniques further in your own projects or areas of interest. Should you have any questions or need further clarification on any of the topics we've discussed, please feel free to reach out.